Welcome back to another exciting chemistry lesson. In the previous lesson, we learned how to draw a Lewis dot structure. Now in this lesson, we are going to look at drawing some of the exception to Lewis dot structure. And this exception happened because of the restriction of the surrounding atoms, especially the halogen and the hydrogen. Because halogen, they only need one more electron to be stable, so therefore they're not going to be able to make double bond or triple bond. They can only make single bond. So again, the exception happened because of mainly the halogens on the surrounding atoms. So let's look at the two common exceptions. The first one is incomplete octet, and this happened with boron. It is stable with only 6 electrons. When normally octet, we require to have 8. And then we have the opposite of incomplete, we have the expanded octet. That means this central atoms can have more than 8 valence electrons. In this case, this happened because of atoms that are in energy level 3 or higher. It has a D sublevel, which allows it to have more than 8 valence electrons. So the expanded octet happened to atom with energy level 3 or higher. Now let's go back and draw every single one that we describe here. First we have BF3. So for boron, okay, we are going to use the same step. Boron is 3, F is 7, and there are 3 of them, so 7. What is 7 times 3? 21. 21 plus 3, that's 24. So now boron, we know it is in the center where fluorine is surrounding. Because remember, fluorine is one of the most electronegative. Then we go to step 3, draw a single bond, and we just use what? 6 already. That gave us 18. Now we are going to place in the lone pair around the central atom to make sure they are octet. 1, 2, 3, 4, 5, 6. And there you go. We just use, what is 6 times 3? 18. So we have 0. There you go. And that is the complete. So this is a complete picture for boron trifluoride. Now let's go to the expanded octet. We have PCl5, which is phosphorus pentachloride. So in this case, P is 5. Okay, P is right here is 5. Cl, just 5 of them times 7. What do we have? So what do we have here? 7 times 5 is 35 plus 5. That is what? That's 40 total. So now we have P versus Cl. Of course, the halogen are more electronegative. So we have Cl, chlorine, 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 and chlorine, and 1 right there. And now we're moving on to the single bond. 1, 2, 3, 4, 5, which is step 3 right here. So how do we use already? 1, 2, 3, 4, 5. So that's 10 minus 10, give us 30 left. Now we're going to step 4, make a lone pair so that they all have octet on the surrounding atom. Okay, you see how that works? And again, we have 6 of them so we use 6 for each one of the surrounding atom. What is 6 times 5? 6 times 5, that's 30. So we have 0 left. And there you go. That is phosphorus pentachloride. Now let's go on to the next one. Then we have SF4, which in this case, S is in group 6. So it has 6 plus 4 times 7. What's 7 times 4? 28 plus 6, that is 34 total. So now we know S is in the middle, okay? And then fluorine on the surrounding. And there you go. So we have 1 single bond, 1 single bond, 1 single bond. And how many do we use already? Well, 2 times 4 is 8, okay? So how do we have left? We have 26 left, okay? Now we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And we did the same thing to the surrounding atom. Again, to make sure it's octet. So we use 6 for each. 6 times 4 is what? That is equal to 24. What is 26 minus 24? Is 2 left. So guess where the 2 going to be? In here, in the central atoms. Because we cannot make any double bond because of the halogen limitation. Now let's go to this one here. XeF4, okay? Xenon and fluorine. So xenon, if you remember, is one of the noble gas. And this is in what? Group 8A. So therefore it's 8 and plus 4 times 7. In this case, what do we have? We have 7 times 4 is 28 plus 8. That's equal to 36. And now let's continue to draw. We have xenon in the center. We have fluorine, there you go. Okay. And draw the single bond. Okay. So now we go in and put the electron on the surrounding atom. So that way it is all octet. So we have used 8 for the single bond. which in this case, 36 minus 8 is 28, okay? So what do we have next? So 28, in this case, we have 6 of them on each one of them. 6 times 4 is what? 6 times 4 is equal to 24. So 28 minus 24 give you 4 left. So guess where the remaining electron is going to be? In here. And there you go. So as always, follow the steps to draw the Lewis dot structure. And be careful when you have a compound that has halogen, because again, halogen is restricted to make only one single bond. The same thing like hydrogen. And this forces us to rethink about the possible exception. And as always, if you have any question, take a picture, put it in a forum, and then we will help you from there. And we'll see you next time on another exciting chemistry lesson.